Okay, so we're going to continue on. Here is the picture I'm looking at to ask you these questions in case you think I'm crazy, which I know you think I'm crazy, but still. And then we have the zygomatus major, makes you smile, mentalis, platysma. We talked about all these in this picture here. So you are going to need to know not only these, although it is very good that you know what muscle does each of these pictures. I probably will not use every single picture on an exam, but you should know them. And you're going to need to know a majority of these as well. So take your time studying these. All right. We chew and we masticate. Do you remember how we chew? We mentioned it in the bones section of this course.
Elevation and depression.
So good, Thomas. We chew by elevation and depression. So up, down, up, down, up, down. What's actually happening in our jaw is also more of a grinding too, at least along the back molars on either side of your face. If you use both sides of your jaw for eating, I don't, because I have a really bad cap that was put on wrong and I'm too chicken to go get that fixed because it hurts so much. And so I just only chew on this side of my mouth and I'm probably causing massive problems by doing that. Don't be like me. Okay. So to move your mouth to masticate, which is chewing, you have 4 pairs of muscles that are all innervated by cranial nerve 5. If you don't know your Roman numerals, you should probably at least learn 1 through 10, but this is 5. So, and once again, we talk about the cranial nerves and you have to name them next section in the nervous system. The prime movers are the temporalis. Let's go back. No, wrong way. Oh, okay, that's fine. The temporalis along the temple here. And then the masseter there, that big piece of muscle wrapping around the lower jaw hinged area right there. So those are your primary movers. Then you have the buccinator as well, and a grinding movement from the pterygoids. Do y'all remember those pterygoid processes in the bone lecture in the face? It doesn't matter because that was last text, right? You already forgot it? Okay. Sure. So prime movers of the jaw, temporalis, and masseter, that is for the elevation and depression, chewing role in the buccinator, and then the pterygoids as well. Sorry. And then muscles promoting the tongue movements. You actually have, like the tongue itself is a huge muscle. And then you have 3 anchors that move that tongue around, you know, so that we can speak and move our tongue into different areas of the mouth to make different noises and also to push around our food as we need to. You have the genioglossus, the hyoglossus, and the styloglossus. Sorry. So temporalis, masseter, buccinator, and I'm actually going to go back to here so you can see them. Temporalis, masseter, see how it's being hidden by the platysma, that is overlapped by the platysma, and then the buccinator here, which is hidden by the zygomatic minor and major and the risorius. So that's why they've moved them out of the way so you can see it here. Then you have, the pterygoid processes, all right, little processes projecting off the skull and process into the temporal bone of the jaw. So if we took that masseter that was wrapped around and hinged along the cheekbone here, if we unwrapped it, you can see the pterygoids better. And those are involved in that grinding movement I talked about back along the molars, not molars. Then the tongue itself is a massive muscle, but you have, nice drawing of that. You have muscles that help move the tongue itself. It's anchored way down, not sort of in the throat, kind of in the throat, along the hyoid bone. Remember that hyoid bone? What is so special about the hyoid bone?
It's not connected to any bone.
It is the only bone in our body that is not connected to another bone. Very good. Yes. You have the genioglossus here, the styloglossus, reaching up to that styloid process, if you remember that from the cranium. And then the hyoglossus, that of course anchors to the hyoid bone. Hyoid, get it? Yes, good, got it, good. Oh, yes. Oh, well, also you would probably cause your trachea to collapse as well if you're breaking your hyoid bone. Don't break your hyoid bone. Don't break your throat, basically. No, don't break.
It's more, is it true that if you get punched really hard in your Adam's apple, you die?
Well, yeah, but that would be because you're collapsing the trachea again. Why are you getting punched in your Adam's apple? Look, the first rule of Fight Club is you don't punch people in the Adam's apple, but we don't talk about that. So, movement of the throat and swallowing. Swallowing takes all of these neck muscles to push the fluid or food or whatever you're swallowing, saliva, down into the esophagus. So you have the sternocleidomastoid. Remember, that's the one that's running from the occipital projection at the back of your skull down and across your neck. Oh, down and across your neck to your collarbone. So that's how it runs there. And it allows your neck to do this. Like the bone axis allows this, but the sternocleidomastoid also is what allows the turning of the head movement. It divides next into two triangles. You have an anterior triangle here, and then of course a posterior triangle that's in the opposite shape. So the point is, where's my hair? The point of the triangle is up here, and then it breaks it down to the back. So the anterior muscles are divided based on location. You have the supra. What does supra mean? No, it's not a Nissan. Seriously. I mean, is it a Nissan? I don't know. But
it's a Toyota.
The Toyota. Whoa, you got schooled, man. Okay, but what does supra mean? It does mean above. And what does infra mean?
Below.
Below.
Inferior?
So we're above and below the hyoid. So there you go. Then you have the tongue and the buccal muscles pushing the food back and forth, blah, 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 blah. And it creates a little ball of food. It's called a bolus. It pushes it to the back of the oropharynx. And then the sternocleidomastoid, the suprahyoid, and probably part of the trapezius move when you swallow. And as that happens, the epiglottis, which is a piece of cartilage, is pushed over the larynx in a good day to prevent food from going down your trachea. And food is not pushed. No, the esophagus does not. How do I say this? If the epiglottis doesn't close, food doesn't go to the esophagus. The trachea is the main pathway down your throat. So the epiglottis has to close for food to have no other option but to go down the trachea. But the esophagus, the esophagus is a secondary pathway to the trachea. So the epiglottis closes over the larynx while muscles in the walls of the pharynx, the upper throat, propel food toward the stomach. The first inch or so of the esophagus is innervated so that you feel food as it's pushing down, and then, or cold or hot or whatever. And then the rest of it is involuntary, and it pushes food down to your stomach through the process of squeezing and releasing the muscle. And that is called what?
Digestion?
No, not digestion. It's a muscle movement of involuntary, like you don't control it at all. The muscle squeezes and releases, and it does it in waves down the entire digestive system, actually, but it has a specific name. That movement does. Starts with a P. I don't know if the camera flips that for you. Anyway.
What's the second letter?
E.
Perry something?
Perry something. Anybody want to know what the something is? Or does anybody know what the something is? Oh, children. Peristalsis. Peristalsis. You don't emphasize the E. So peristalsis. What? But what'd you say? Okay, what would happen? What would happen? So the suprahyoid muscles involved in swallowing and moving the hyoid bone and the larynx and blah, 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 form the floor of the oral cavity. So down here, you know, the soft area down here, they anchor the tongue, they elevate the hyoid bone, and they move the larynx during swallowing. The infrahyoid muscles are 4 strap-like muscles. You strapping young muscles, you. And they depress the hyoid bone and larynx during swallowing and speaking. So let's look at these. So I don't know how, this is not going to be a slide that you need to know as much as other slides. Let me say it like that, okay? But you have the suprahyoid bones forming the base of the oral cavity, anchoring the tongue, elevating the hyoid here, which are the stylohyoid, the mylohyoid, and the digastric anterior belly and posterior belly, along with this piece of cartilage here down the middle. Because remember, in utero, both sides of your mouth have to fuse together. And this is the median raphe, which is a fun name. You should name your kid Raffy. I'm not naming my kid Raffy, by the way. The holes, like you mean these little, oh, these? What is the name of this opening in the jaw?
Oh, this is like a general term for a hole.
Yes. He's talking about these 2 openings in the mandible here. What are these called? It was on your test.
Yeah.
The foramen?
It is a foramen because it's an opening, but which foramen is it?
Mandibular foramen?
Oh, you tried. No, it's the mental foramen. Mental foramen. Why? I don't know, but that's what it's called. Okay, and the 4 strap-like, here's a strap, there's a strap, here's a strap, there's a strap, you see it. All the straps, you can learn these for funsies if you want. You got the sternothyroid, the thyrohyoid, which is, okay, these names are hilarious. The omohyoid, the sternohyoid, along with the sternocleidomastoid and another, oh, the other piece of this, the omohyoid. Oh my God, omohyoid. Right, I'm not gonna test you on the names that sound exactly the same, but you do need to know infrahyoid and suprahyoid in terms of relation to the hyoid and what they do. So let's go, oh, I'm sorry, I also forgot to show you. And then here is your trachea back here, which we all know we can feel our trachea if we feel along the throat and we feel the ridges there, those cartilaginous ridges, that's your trachea. Men, you have a much more pronounced Adam's apple once y'all hit puberty. That's in the way, but the trachea is there. Ladies, we have the same tissue that creates men's Adam's apple. We just don't have it projected out like they do. It makes your voices deeper. It's part of puberty. And then here is the thyroid gland, which is actually very important because it does a lot of things. Wink. Okay. Here's a lot more muscle names. And I told you that the whole reason of me doing this is so that you hear the correct names. So here we go. You have the tensor veli palantini. You have the levator veli palantini. What does levator tell us it does?
Elevate.
Elevates. Very good. There's that styloid process again. What does the styloid process help in? One more time for Big Fudge. It's something to do with how we grind up our food.
Does it move the mandible up and down?
No, remember that's the masseter and the buccinator. Yes, but it's something with how we grind our food. Is Thomas the only one there? Not that I don't appreciate you, Thomas.
No, I'm right here, Miss Moore.
Okay.
Can you repeat the question?
What is the styloid process involved in?
Hearing? No.
The clue is that it's something to do with how we grind our food.
It's a really lovely question, Miss Moore.
So they help you grind your food. Good Lord. Okay. You have the superior pharyngeal constrictor. Right? Because snakes that are named constrictors because they squeeze. The middle pharyngeal constrictors, by the way, squeezing will help swallow. Hyoid bone, thyrohyoid membrane, right? Because tendons and ligaments, oh my. Oh, okay, go away. The inferior pharyngeal constrictor down here, and the esophagus. Here's your buccinator again. There's your mandible with that mental foramen. Here's the cut mylohyoid, so that it's out of the way so that you can see the geniohyoid, which is now a new name. The hyoglossus, which, what does the hyoglossus help do?
Does it keep the hyoid bone in place?
No, but probably yes, but also no, that's not its main function. Scroll back to your slides. What does the myohyoid do? So loose. Here I am trying to keep myself safe, and my mask is like, nah, we don't need that. It involves your tongue. What does the myohyoid do?
Hold the tongue in place?
Or it helps move the tongue. We'll say that instead. It helps move the tongue. Here's your thyroid gland again, which you'll learn about in the endocrine system in 14. No, this is anatomy 2402. And then thyroid cartilage and the trachea there. Okay, movement of the neck and spine. Yep, we'll keep going. Anterolateral front and side neck muscles move the head. The intrinsic muscles of the back extend your trunk, allow you to have that full upright position and maintain your posture if you're smart enough to maintain good posture in your life and not do what I was just doing and slumping over like this. Okay, because it's really bad for your back. So those muscles, majority of them is going to include, or the majority muscle, the big muscle is the sternocleidomastoid, okay? It runs from the back of the skull and the occipital protuberances down to the cleido, which is clavicle, and sterno, which is sternum. And actually, the way the word is written, apologies, it goes from the sternum and the clavicle to that occipital protuberance in the back, or the occipital mastoids in the back. Because the first word is where it originates from. Then you have the scalenes. And you're gonna have to know the scalenes just because I really like the name. So, you know, I'm a teacher, I can be wild like that. You have the anterior, posterior, and middle scalenes, and they are all involved with being able to move your head and neck. Whee! Which also means you can really damage them as well if you are doing anything that causes any kind of whiplash. So there you go, all of those. And then let me do something real quick so I can see, so I can see where the splenius capitis is. Okay, so it is under. So if we move the sternocleidomastoid, then there is your splenius capitis. So let me go back here. So here's the splenius capitis. We're at the back, we're in behind, we're in the dorsal part of the body. Ooh, medical terminology. It is connected to the spinous processes of the vertebrae. And then you have the splenius cervicis as well. So cervicus tells you it's going where?
The cervical vertebrae.
Very good, yes. Cervical vertebrae, so it's behind, it's tucked behind the splenius capitis, which is coming from where? Well, the skull, yes. Okay. Oh, then we get into the layers of the back. And I will admit that I learned these like one time in my life and then promptly forgot them, except for the latissimus dorsi, because the latissimus dorsi and the trapezius muscles cover everything else. So unless you're digging down through, let's say, a cat, or in medical school, if y'all go to medical school, you'll be doing this to a human, you can't see them. So you'll have to remove the trapezius and latissimus dorsi, and then you'll be able to see all these minor muscles of the back as well. Okay, I'm just gonna name names because that's all I can do. I can't, you have to learn where they are. I can't teach you where they are. We have the longissimus capitis. So it's coming from the skull, going down to the spinous processes of the vertebrae. Processi? That's a weird one. You have the iliocostalis cervicus. So, crap, I can only think of the hip right now. There's another ilio. Anyway, costalis means rib, and cervicus, you're in the neck vertebrae. Longissimus cervicus, so you're still in the neck vertebrae area and it's a longer muscle. Iliocostalis thoracis lets you know you're in the thoracic vertebrae. And then you longissimus thoracis. And then you get a new one, the spinalis thoracis. Then you have your erector spinae, which are iliocostalis, longissimus, and spinalis. At least there's a theme here, right? And then you have your iliocostalis lumborum. Okay, so these are coming from in between the ribs down into the lumbar region. Here is your external obliques, which are what allow you to twist your body side to side. When you're doing exercises or any kind of twisting movement, your obliques let you do that. You have externally and internal. Over here, you have the ligamentum nuchae, because this is a nuchal fold right here. So remember the nuchal fold in the skull? What's that little kind of rounded indentation at the back of the skull? Sorta, y'all remember this? Sorta? Okay, I'm gonna say y'all do. So that's where this ligament is coming from. And then you have, along with the longissimus capitis up here, you have the semispinalis capitis and the semispinalis cervicus. So these are partway attached to the spinous processes, semispinalis thoracis, surprisingly not a semispinalis lumborum, but we had the quadratus lumborum down here. Muscles, 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 muscles. Am I gonna go crazy on this slide? Possibly. Maybe you should know iliocostalis, longissimus, spinalis. When we are looking at these words, we are in the back. That is what I do. Multifidus, which is a fun name, is clearly this muscle, but I have no idea what it does. But all these help elongate, straighten your back, keep your posture in place, right? Because they're right along that center spine. So when you need to stand or sit up straight or stand up straight, they're the things that are going to tighten to make you, to give you that, you know, up part, the posture there. Also, if you slouch a lot or you're on a couch a lot or you sit a lot, these are what is hurting you in your back as well. Oh gosh, we're not going to worry about this slide at all. Hey, you have muscles in between your vertebrae. Cool, right. And we're going to stop at thorax. What slide am I on? 45. It's only 4 slides. Okay, we're going to do thorax and then we'll stop. Right, so you know that you inhale and you exhale, and we call that inspiration and expiration. And when you add inspiration plus expiration, you have a when you breathe in and out, you have done an entire what?
Respiration.
Respiration. And respiration is what we count, right? We count respirations in our patients. So it's in and out is one respiration. In order to respire, we have that diaphragm muscle, which is separating the thorax from the abdomen and arching kind of along the rib space. It's higher than everybody thinks it is. Everybody thinks it's way low. It's actually kind of really high. And then you have your external intercostals. The external intercostals in the diaphragm are the muscles that you can move to force air in if you want to. But the lungs, the tissue of the lungs, you cannot move. Contraction of these muscles enlarges the rib cage. So at rest, the diaphragm is naturally bowed. And when you breathe in, the diaphragm flattens out. And then at rest, the intercostal muscles are naturally spread apart. And when you breathe in, they contract to pull the ribs out. And I already said the diaphragm divides the thoracic and abdominal cavities. Expiration is the opposite. It is the relaxation of the external intercostals in the diaphragm and the contraction of the internal intercostals. So external on the outside, internal on the inside. I hope you understand that. Which means if you were to cut through this tissue, let's say you're going on a stabbing rampage, don't stab people, but you would go through the external muscles first before you hit the internal intercostals. See here, if these were overlapped, these muscles would kind of just swoop right here, and then you would see the intercostals hanging out underneath them. Here is your diaphragm. This is as if we are looking at it from underneath, I believe. Yes, underneath. You have foramens, obviously, because you have an esophagus that pulls through here. You have a inferior vena cava that comes through here. And then, of course, your spine as well. And then the aorta. So we got all sorts of foramens and openings here. And it's just a sheet of muscle. It's really all it is that allows for inspiration and expiration to occur. Kind of necessary, believe it or not. Here it is in a human body. Let me orient myself. Okay, so this picture, the spine is at the back and here is the abdomen. In this picture, the spine is here and here is where the abdomen would be as well. We are above the, we are below the diaphragm here in the abdominal space. We are above, oh, sorry, too far. We are above the diaphragm here is what I'm seeing. Here is our pericardial sac and pericardium. So the heart should be sitting right here, but we removed it and cut all the tissue out of the way. Here's your esophagus. Here is your aorta. There's your spine. And then you can see this, it's just a sheet of muscle. It almost looks like your stomach, to be very serious. And that's why I was really confused for a minute. But it's just a sheet of muscle that is connected all the way around to the serosa. So it is kind of a sealed off space between the thorax and the abdomen. But of these 4 slides, you're going to need to know the writing here more than anything. We have a lab? What? Oh, sure. Yeah. Okay, so we're going to stop there. We're going to start in the abdomen next class. I did expect this PowerPoint to take about 2 weeks, and it looks like we're right on target for that, which will put your exam at the end of next week. The 13th, 14th-ish. So good. So you don't have to be taking it over Thanksgiving. That's nice. Any questions about any of that? The muscles are difficult. There's more of them than bones. Questions, comments, concerns, queries, conundrums, contemplations? Ooh, I'm getting good at this. What else we got? Okay, that's about it. Any of that? Anything? Anything to say at all? That you aren't really here? You're just making sure that you're on this recording so that you look good in your future?
Go Biden.
Go Biden. Yes, well, yeah, I was not expecting to not see y'all for 2 days and still not have an answer to our topic last class. Whatever happens, you're going to be okay because you were okay the last 4 years too. All right. It is a very important thing for us, but also here's America and the government and whatever, and here's us just living our little lives. So you two are hilarious and distracting. So just live your life the best you can, regardless of what happens. Because at this point, I'm not even sure anymore. I went to bed on election night fully believing Trump had won again. I woke up, it was a different story. And now it's just like,
Nevada's taking this sweet ass time.
and they have a right to, and you should be happy about that, because that is what democracy is about. Because they are making sure that every vote that they have is counted, and that is the point of all of it. So even if it takes some time into next week, that is something that y'all should be proud of and applaud about this country, that they are taking their time. Now, do I agree that they are taking too long? Yes, but that's because we want resolution. People don't like anxiety and uncertainty. It's a physical attack on our bodies to us. So, okay, but you should be pleased that Pennsylvania, Georgia, North Carolina, and Nevada are still counting. That is the whole point of voting. Okay, all right. That's it, because, well, actually, we're not really having class for biology, but if people pop in, I need to have this stopped and recorded so that they can get in. So I will see y'all later. It was really good seeing some of your faces today. Yay. You spelled Espanol wrong. Oh, God. All right, I love you all. I'm ending this. Goodbye.